All right. Good evening to you guys, and welcome to another session for statistical techniques. So today we're just going to we're going to continue with the introductory, but today we'll be going into the stuff itself. Last time we were just doing an assignment just to give you an overview of how we'll be doing your assignment as well and how I deliver the content of the module, right? Now, let me share the slide of the stuff that we're going to be doing today. All right, so my name again is Kudasbata for those maybe that don't know me. And I'll be taking you for statistical techniques this semester. All right, so now, since this is an introductory lecture, we just want to see the overview of this lecture. So we're going to talk about what statistics is in general, the types of statistics, data presentation, measure of central tendency, and the measure of dispersion, right? So generally, statistics is all around you, right? So as long as you are in a company, you are dealing with numbers, the probability of you that you are dealing with statistics is very, very high. When we're talking about income, talking about profit, turnover, levels of production, forecasting, and so forth, that is statistics, right? So generally, statistical reasoning is needed for you to be able to accurately interpret results. So just like we said last time, this is just a recap, right? I did give a definition of what statistics is in the last lecture. So just for repeat's sake, right? It is the gathering and the classifying and summarizing of data, and then you interpret it in order to draw conclusions from the data. So the data that you draw conclusion upon is then used for decision-making purposes. So now let's look at the types of statistics that we are going to be looking at in this module. So the two types of statistics is, the first one is what we call descriptive statistics. Generally, this type of statistics is used to describe data. So it's used either to summarize or to describe data. You describe or summarize using the frequency, like what we're doing, when we're grouping the data, the percentages, the measures of central tendencies, that is maybe your mean, your mode, your median, the measures of dispersion, we're going to talk about them later on. That is your standard deviation, your range, right? And also by looking at the shape of distribution, we're talking about the normal distribution, right? And now the second type of statistics is what we call inferential statistics. So now this type of statistics, it is used to make inferences, or where you generalize what you find on a population, but that generalization on that population will be based on a symbol that you would have drawn up. All right, so now let's look at ways of presenting data. When you want to present data, right, you have collected your data, you have summarized your data, you have interpreted your data, you have analyzed your data. Now you want to present that data to your audience. So that's what we're going to look at now. So the information obtained from a statistical analysis is meaningful to business managers only when it can be interpreted, right, and communicated effectively and concisely, right? So it is customary to convey such information through the use of summary tables. So one of the easiest way of presenting data is using summary tables and charts, right? Now, tables and charts, they convey information more vividly and quickly than written reports, right? So when you are employing a table, right, and the chart, you are trying to bring out your information vividly. You will see, I'll give you an example of what I'm talking about, right? One such compact and efficient way of presenting data is in form of a table rather than to give it as a paragraph or as a report. right? So using a table to list data according to category is often much clearer than writing out all the information in a paragraph. So you can see from this example, right? So you can see that we have information here. It's talking about a university, some stuff, you know, the university, how it's ranked, and so forth, and the number of people that will be there, right? So here, you know, you are even, I myself am even feeling tired to read this. It's too much information, right? But on the right side, you can see that the same information that is on the left side is the same information on the right side. So I can actually say from the table, okay, I see that there are 3 columns: institution, rank, and holding. So this is the university, the rank in the world, and then the number of students that are enrolled, right? So you can see the beauty of using tables. It brings out information more vividly than in a paragraph. So it's not always that you have to write paragraph when you are presenting your data. Understand what type of data do you want to present to your audience and try to make it as vivid as possible. Now, since we're talking about presenting what we call it, information in a table, right? There's what we call a frequency table, right? So a frequency table, I think we're now repeating this. You remember when I told you that some of these things, if you don't understand, don't have a problem, because we're going to repeat it. So a frequency table, generally what it is a table that shows the number of occurrences of a variable falling into a specific range or category. What am I trying to say? Let me explain this using this example, right? So this example is there in your study guide. So consider a group of 47 males, right, of various ages. So 12 are between 20 to 29 years of age, 13 are between 30 to 39 years of age, 7 are between 40 to 49 years of age, 8 are between 50 and 59 years of age, while the rest are 60 and 69 years. So now what we want to do is we want to put this information in a table. So remember, these men are being grouped, but they're being grouped according to the number of years that they fall into. So a man that has got age that falls into 20 to 29, you put in that group. So when we are saying a frequency table shows the number of occurrences of a variables falling into that specific range, we're just saying we are showing the number of people in this case that fall in the category of 20 to 29. Here we are showing the number of people that fall in the category 30 to 39. So here we've created now the frequency table where we have the class interval in the frequency itself. And now the class interval, remember we said for each class interval, there is a lower limit of that class and the upper limit of that class. So this is the lower limit of this class and the upper limit of that class. Lower limit of this class and upper limit of that class, right? And these are the frequencies, the number of people that fall into that bundle, that fall into that range, that fall into that category. So immediately we can make this following conclusion by just looking at that table. One, we can see that the majority of males are young. Why am I saying so? We can see that these 2 classes, obviously, they are representing the younger generation because they are less than 40 years. So you can see this is the largest number, which is around 25. So 25 out of 47 are young, right? So you can also see that the most males lie or have an age that range from 30 to 39, because this is the highest frequency, right? And then you can see that if we add all of these numbers, they have to give you 47, right? So that is a frequency table. So last week I showed you how you can create what is called a cumulative frequency table. So there are 2 tables, right? There's what we call a frequency table. A frequency table has got 2 columns, class interval and frequency only. But a cumulative frequency table has got 3 columns where you've got an interval, a frequency, and a cumulative frequency, right? So now what you need to do is, in this example, in your study guide, right, you were given a class. Consider a class consisting of 100 students, right? Suppose the teacher gives the entire class a statistics test. right? Which has a maximum mark of 100, right? Upon marking the scripts which are in no order whatsoever, he puts the marks into a table as shown. So now he's just recording the marks without putting them in an order. So he's just taking note of those marks. So you can see that those individual data points, they are 11, they are 100, representing all the 100 students, right? But now we want to group this, right? When you group it now, that's where you have to create this what? You have to create this cumulative frequency table. Where now I showed you last time, where you are just trying to find how many students have got a mark from 0 to 9, it's 1. How many students have got a mark from 10 to 19, there are 2, and so forth, right? So now, so that is how you what? You create this table. So when it comes to the cumulative frequency, right? When it comes to the cumulative frequency, remember last week, okay, let me put my, let me try to write on the screen here, right? So that you understand, just a recap, right? Just a recap there. So we are saying, all right, not next. Okay. All right. Okay. So let me go back. All right. So when we're doing cumulative frequency, we said for cumulative frequency, all right, let me write the formula down there, right? When we want to calculate the cumulative, okay, what's happening to my okay, just give me a moment there. All right, so cumulative frequency, right, is equals to the frequency of the previous class, right? Plus, so is the cumulative frequency of the previous class, right? Is the cumulative frequency, let me say CF of the previous class, right? Plus plus the frequency of that current class, right? So generally that is how you calculate your cumulative frequency, right? So we are saying that in this case, right, if we want to find the cumulative frequency for this class, we are saying that cumulative frequency of the previous class plus the frequency of that class, which gives us 3, right? And then here, if you want to find the cumulative frequency for this class, it's cumulative frequency of this class plus the frequency of this class to give us this, right? Same with this one, we say cumulative frequency of this class plus the frequency of the current class to give us this, right? Same again with this class, we say this plus this to give us that. So that is how you calculate what? You calculate the cumulative frequency of all those classes, right? Now, so those are the 2 types of the tables that you'll be using. It's either you draw a cumulative frequency table or a frequency table, depending on the question that you are asked. Generally, the difference is the cumulative frequency table has got an extra column of cumulative frequencies. That's the difference between the 2, right? So the other way of visualizing data, of presenting data, is using graphs or charts, right? So a table is a useful way to present detailed data, but a picture or a diagram is more powerful if you want to focus attention on a particular aspect, such as a dominant feature or a trend. So if you want to show a peak, if you want to show a trend, then it's better for you to depict that in a picture rather than to do it in a table. Right. So there are many different types of graphs which you can use to portray data. So you can use a line graph, you can use a bar graph, you can use a pie graph. So let's look at line graphs, right? So this is an example, right? We've got a company that has got has been operating for these years, and these are the respective profits, right? Now, if someone says, show us whether, or tell us whether the company had a profit or losses from 1997 to 2002. When you're looking at the table, you can't tell whether there have been losses or there have been an increase in profit, right? The only way, or the easier way for you to see, is to present the same data in this table as a graph. So you can see that this graph on the right side is the same information that is being depicted in this table. But now here you can easily see, oh, the company has been operating at a loss. You can see, because you can see that the sales now, they are dropping, right, as the years are commencing, which means that they are now having some losses that they are encountering. So the trend can be better depicted using the line graph. That is the beauty of using diagrams and pictures more than tables, right? Now there's what we call bar chart. A bar chart consists of series of bars, and the length of each bar representing the value of the variable being plotted. So these bars, they can either be drawn vertically or they can be drawn horizontally. So these are the two types of the graph. So it's the same information that we were showing you earlier on, right? The profit between 1997 to 2002, right? But now we are just showing it in form of a graph, of a bar chart. Right now, what you need to understand, don't worry about these things. You won't draw them by hand. Like I said, later on, when we come to a place where we have to use Excel, I'll show you how to draw maybe some of these things using Excel. Right, so that's the beauty of this course. You are not going to draw these charts or graphs manually. So we are just explaining them to you for you to understand the types of methods that are used to present your data, right, to your audience. Now let's look at the pie chart. So a pie chart is usually used when proportions are to be depicted relative to a whole. So when you want to compare a certain portion, right, in relation to the whole portion, then you will have to use what is called a pie chart. So in essence, it is a circle divided into segments with the size of each segment proportional to the value of the variable relative to the whole, and is usually expressed in terms of percentages. So let's look at an example that is there within your study guide. Consider a father who gives spending money to each of his three sons, right? Josh, who is the eldest, gets 120 rand. Then Matt, who is the second elder, gets what? Gets 80 rand, right? And then the youngest gets 50 rand. So we want now to express the amount that each child got, right, as a percentage, right? So what you need to do is, firstly, you need to calculate the percentage in terms of the total amount that the father gave out, that each son received. So first son got 120, the second son got 80, the third son got 50. So if you add all of that, you get 250. So now to find the percentage of the amount that the first son got, you will say 120 over the total amount that was given, which was 250. And then you see that Josh got 48%. Then Matt was given 80 out of 250. That gives you a percentage of 32. And then David was given 50 out of 250, which gives you a percentage of 20. So when you plot these percentages in a bar chart, right, in a pie chart, you see that this is what you get, right? So this is 48%, this is 32, this is 20, right? So you can see that this is Josh, this is Matt, this is David. So you can easily see, right, the proportion, right, of the amount that Josh got in relation to the whole amount. Now, the other type of chart that that is also used in statistics is what is called a histogram. So a histogram is a special type of a bar chart. All right, it is a bar chart that displays what is called the frequency distribution. So when you have a frequency table and you want to plot the frequency table in form of a bar graph, that type of a bar graph is what is called a histogram, right? So you must understand that. So now we are done with data presentation method, right? We showed you that there are tables, there are bar charts, right? They are line graphs, they are pie charts, right, and so forth. So now let's look at the measures of central tendencies. We talked about it briefly last time. So now we are going to get into much more detail, right? So now a measure of central tendency, like we said last week, we said it is a single value that attempts to describe a set of data by identifying the central position within the set of data. So this section that we are doing, if you go check in your study guide, you see that it is under what is called management statistics, right? So this type, when we're talking about measures of central tendency, when we're talking about measures of dispersion, the type of statistics that we are dealing with is what is called descriptive statistics. These are types of statistics that we are going to use to describe the set of data. So that is why we are saying you are now using a single value to describe. Why? Because it is descriptive statistics. It is statistics that is used to describe, right? So you describe using a single value by identifying the central position within that set of data, right? So measures of central tendencies, they help you find one, what is called the middle or the average, right? Or the mean of the data set. So the three commonly used numerical measures of central tendencies or measures of central location is what we call the mean, the median, and the mode, right? Before we start to show you the different types of formulas that are used for these measures of central tendencies, what you need to understand is the data is divided into two types, right? Just a recap, because I explained this last week. We said there's what we call ungrouped or raw data, and there's what we call grouped data. And I gave you an example of a lecturer that is coming in the lecture room, right? And grouped data is when he comes and he says, oh, those with shoe size of 7 stand up. Then when he writes down, he says, those with the shoe size of 7 stand up. So he is gathering the data from the experiment or study. He hasn't sorted it or he hasn't grouped it yet. The data is still in individual data points or as a list. So that is ungrouped data. But now grouped data is when he says, okay, now those that have got a shoe size between 6 and 7 stand in that corner. He is now grouping the data in those given intervals. So in other words, it's just bundling together the people in specific categories, right? So that is the difference between ungrouped data and grouped data. All right. So now what you need to understand, the reason why I'm taking time to explain and to differentiate between ungrouped data and grouped data is because the formulas that are used for mean, mode, and median for ungrouped data, they are different from the formulas that are used for the mean, mode, and median for grouped data. So what we're going to do today we're just going to look at maybe for ungrouped data, right? And then we will see if we are not yet saturated, right? Because sometimes when we give too much information at once, you don't want people to have too much information that they will fail to process. So we'll just see whether we are going to look at both ungrouped data and grouped data, or we're going to look at ungrouped data first only. All right, so now let's start by calculating the mean for ungrouped data. So when you are dealing with ungrouped data, like what we were doing in that assignment, you use the formula X bar, right, or mean, which is equal to the sum of all the observation. You add all the various observations that you have been given, divided by the number of the observations, right? So generally in what you call statistical notation, it is equals to summation. So this E or 3, or this E that is reverse, capital letter E that is reverse, it's a representation of summation. So you're saying you're summing all the values of X and dividing by N. So don't worry, we are going to be, when we are now doing like when I'm using Excel to write the equations, you realize that is the notation that we'll be using. Or even if you check in your study guide, some of these formulas will be given in this notation, right? So now we have been given an example that there are marks that are received for a spelling test for 7 students, right? So the first student got 85, 48, 52, 64, 64, 80, and 75. Now they are saying what is the mean. In other words, they're just saying what is the average. So how many people took part? So it's 1, 2, 3, 4, 5, 6, 7. And these are the values. So according to this formula, we need to sum all the observations. So we say 85 plus 48 plus 52 plus 64 plus 64 plus 80 plus 75. Now, when we add this, we need to divide by the total number of people who took part. And the total number of people who took part is 7. So we then add all of this, divide by 7, and then you see that the average mark is 66.86%. All right. So now let's look at what is called the median, right? The median for ungrouped data. All right, so the median for ungrouped data, the median is the middle number of an ordered set of data. So this is a keyword, right? So let me do this, right? I just want to highlight something there. All right, so just give me a moment. I'm just doing it in the background there. All right. Okay. All right. Okay, so I just wanted to highlight this, right? To put that in bold. The median is the middle number of ordered set of data. It's not just the middle number of any data set of data, but the data must be sorted, must be ordered, right? Must be sorted in ascending order, right? So you have to sort your data first in order for you to identify the median. So it is always important that when you are given raw data, you must first sort it, even if before you start answering the question. That's why last week I started by what? By ordering it, because in case maybe they asked you to calculate the median, you'll be able to do that, right? You will be able to find the middle number. The only way you can find the middle number is by first ordering it in ascending order, right? So this value, or let me see. I don't know if I've shared this. Let me see. I haven't shared, right? Sorry, guys.
No.
All right. I think I got carried away here. All right, so let me show you. So I was saying, I highlighted this part, right? Where I'm saying that the median is the middle number, right, of an ordered set of data. Okay, so you have to order your data first in ascending order. That's why last week I started by sorting the data first in ascending order, right? Because maybe if we were asked to calculate the median, it would be easy because the data is already sorted, right? So the first thing when you have ungrouped data, sort the data in ascending order, right? Because it will help you in answering some of the questions. So that median, it divides an ordered set of data values into two halves. So it is a value that divides the set of data into two, right? So what you need to do when you are answering, right, or when you are calculating for the median, right? First thing is arrange in ascending order. Then the second thing, you need to check whether, right, whether the data is odd or even. Can you see? That is very, very, very important, right? When I'm talking about odd, an odd number is a number that is not divisible by 2, right? An even number is a number that is divisible by 2. So when you are given, in this case, you are told that maybe there are 100 students, right? So 100 is an even number because it's divisible by 2. But if you are told that it's 19, 19 is not an even number, it's an odd number because it's not divisible by 2. So the first thing is arrange your data values in ascending order. The next thing you need to find is the number of observation. Is it an odd number or is it an even number? If it is an odd number, then it means that the median lies in this position where you are saying n plus 1 is equals to 2. What this means is if there are 7 students, right? 7 is an odd number. So it means if you want to find the position that has got the median, you say 7 plus 1 over 2, that gives you what? 8. All right? So basically that's what it means. Then if it is an even number, like if the students are 8, right? So it means now that you have to first find what is called the n over 2 position. So which means in this case, if there are 8, it means you have to find 8 over 2 position, which is the 4th position. Then when you find this 4th position, you average the data in this position with the next consecutive data. So which means that the value on the 4th position and on the 5th position, you add them and then you find the average of the 2. All right. So generally that is how you calculate what? How you calculate the median. So now let's look at what? Let's look at an example, right? So the first example here is find the median number of cars sold per month by a dealer over the past 9 months based on the following monthly sales figure. So now you can see here that these are the values that we have been given. So the first thing that you need to do is you need to sort or arrange this data in ascending order. So you're starting with the smallest number to the maximum number. That's the first thing. Now that we have done this, we need to check whether if the data is the number of observation, the number of the n, right? If it is odd or even. So in this case, we can see that is odd. If it is odd, we then say n plus 1 over 2 position. That's where the median is. So in this case, we say 9 plus 1, which is 10 divided by 2 is 5. So the 5th position here is where the median value is. So what you do is now you come on your data that has already been sorted. You find the the what? The fifth position starting from the lowest value. So you say 1, 2, 3, 4, 5. So this value there, that is your median. So your median value now is what? It is 34. So how do you interpret this data? Once you have the median, what does it mean? How do you interpret it? So you say, thus the median monthly car sale is 34. We can see that it's 34 there. This means that there were 4 months when the car sales were below 34. You can see that all the values on the left side, they are less than 34, right? So you can say that there were 4 months when car sales were below 34 cars per month, and there were 4 months when car sales were above 34 cars per month. That is the how you interpret data when it comes to calculating the median. All right. So now let's look at another example where now the sample size, right, or the number is what is even, right? So we are saying find the number of cars sold per month by a dealer over the past 10 months based on the following monthly sales figures, right? So these are just the value that you've been given, right? So the first thing that you need to do is to arrange the data in ascending order, right? That's what you need to do, to arrange the data in ascending order. So that's what we do from the lowest value to the maximum value. But since this value, right, is even, then we need to find first the position, the n over 2 position, right? So the n over 2 position, in this case, 10 over 2, which is the 5th position. So when you find the 5th position, you come and you mark it, right? This is not your median. This is not your median, because remember, the median is the value that separates the data into 2 equal parts, right? So what you do is you then find the next value that is next to the n over 2 position. So in this case is this one, right? So you add these two and find the average. Why are you doing it, right? So when you find the average, you're finding the value that is in the middle of these two, right? Because if we don't do that, if we assume and say, let's say that this is our median, you see that this is 1, 2, 3, 4. These are 4 values below the what? Below the median, and then the value will be on the right side. It will be 1, 2, 3, 4, 5. So the value here, 27, is not divided the set of data into 2 equal halves. You can see, can you see that? Even if we do this by taking 34, right? It means that these values before 34, right? They are not. They are 5, and after 34, it's 4. So 34 is not divided the data into 2 equal halves. So we need a value that is in the middle of these two, right? In the middle of these two. So the value there is where this one that we calculate using the average of these two values, where you say 27 plus 34 divided by 2, it gives you 30.5. So 30.5 is here, right? 30.5 is here. So 30.5 now, it means that all these values before 30.5, 1, 2, 3, 4, 5. So there are 5 values before 30.5, and there are how many values after? It's 1, 2, 3, 4, 5. So 30.5 now becomes the median, because it is the value that divides the set of data into 2 equal halves. So how do you interpret this? Because now we have found the average, which is 30.5. We then say, thus the median monthly car sale is 30.5. This means that there were 5 months when car sales were below 30.5 cars per month, and 5 months when car sales were above 30.5. So that's the reason why we want to find the median, right? So that we can divide the set of data into 2 equal halves. Now let us look at the mode, right, of ungrouped data. So the mode of ungrouped data it is the most frequent occurring score, right? Or the number that occurs the most frequent, right? So in this case, let's say we have been given these marks for the learners, right? That's what a test. So you can see that the number that has been repeated the most number of times is 64, right? It has been repeated twice. So it means that this is our mode, right? So just a recap, right? Just a recap, mean for ungrouped data, it is the sum of all the observations over the number of observations, right? And then the median, the first thing that you need to do, you need to arrange your data in ascending order, right? And then you have to check whether the data is odd or is even. If it is odd, your median value, you find it on the n plus 1/2 position, right? And if it is even, you have to first find the n/2 position, and then you average it with the next consecutive data value, right? And now the last part is the mode. The mode is the most frequent occurring score. This is only applicable to ungrouped data, right? So now for grouped data, okay. That's where now this is going to be a little bit interesting, right? So for grouped data, right? Maybe what I'm going to do is I'm just going to look at the mean, because I don't, like I said, I don't want to saturate you with too much information, because here the mean and mode and median, they've got different formulas, right? So okay, maybe let me just brush through, and then next week what we do is we then look at an example, right? Because I have an example here, mean, modal, and then standard deviation. All right, so just bear with me. Let me just explain just a little bit the formulas. Today is just the theoretical part. Then the practical part of it, I'll do it next week, right? So when we're talking about the mean for grouped data now, right? So grouped data, it means that you have grouped that data, right, using a table. So normally you group it using these two columns, right, interval and frequency. But now when you want to calculate for mean, mode, and median, there are extra columns that you must put. You must put a column for midpoint. You must put a column of fx squared, and cumulative frequency, right? So let me explain how you calculate the midpoint, the fx squared. So here we've got an interval, right? So we're using this information here, right? We grouped this information of set of scores, right? And then we got these intervals, right? These 5 intervals. So we found out that 2 of the people had scores that are within 10 to 19, then 5 had scores between 20 to 29, then 6 had scores between 30 to 39, and so forth, right? Now, the midpoint, what you do is when you want to calculate the midpoint, you say the lower limit of that class plus the upper limit of that class, and you divide by 2. So in this case, you say 10 plus 19, right? You get 29, you divide by 2, you get 14.5. Right? 20 plus 29, you get 49, divided by 2, 24.5, right? 30 plus 39, you get 69, divided by 2, 34.5. So that is how you calculate your midpoint there. So midpoint is denoted by the letter X, and your frequency is denoted by the letter F. So this column written Fx, you are simply multiplying the frequency and the midpoint. So you say 2 by 14 by 5, you get 29. 5 by 24.5, you get this value. 6 by 34.5, you get this value. 4 by 44.5, you get this value. And 3 by 55.5, you get this value, right? Now, when it comes to fx squared, what you are just saying simply, you are saying the midpoint multiplied by fx. So you are saying 14.5 by 29, 24.5 by 122, 34.5 by 207, 44.5 by 178, 55.5 by 163.5. Then you get these values here. Then the cumulative frequency, I told you how to do it, right? For I can't repeat that because I already told you, right? So then you need to find another column where you say summation of all the frequencies. Then you get your so the summation of all the frequencies is the total number of people that took part, right? The midpoint, there's no need for you to calculate the midpoint there. And then fx, if you add all the fx's, you get the value there. If you add all the fx squared, you get this value, right? Then when you have this table, now you can calculate your mean. So from your study module, you can see that now to calculate the mean for ungrouped data, you say that summation of fx over n. So what is the summation of fx? Summation of fx, you are saying the summation of all these values. When you add these values, that is this value. The summation of all these values, it's 700 divided by n, which is 20. So in this case, it will be 700 divided by 20, which gives you a mean of 35 cars, right? Now, the median, right? The median, this is the formula for the median, right? So you have OME, which is the lower limit of the median interval. So the median interval, first, you need to, for you to calculate the median for grouped data, you need to find what is called the median interval, right? So the median interval, what you need to know, it is the interval that is the highest frequency. So in this case, this is the interval that is the highest frequency. The highest frequency is 6. So the interval, the median interval is 30 to 39, right? So that is how you calculate your median interval. Median interval, keep this in mind. It is the interval that is the highest frequency. So now that you have highlighted your median interval, for this equation that you apply for the median, right? You need to find what is called the lower limit, right? The lower limit of the median interval. So which is your OME there, right? Then you say plus, then the C there, the C, little c there is the class width. I explained to you last week what a class width is, right? And then here you have n over 2 minus f less than, that is the cumulative frequency count of all the intervals before the what? The median interval, right? Over FME, which is the frequency of the median interval itself. All right, so coming now to this example, how do we calculate the median? So we have to identify first what is the median class. So in this case, the median class, it is the class with the highest frequency. So this is the class 30 to 39. So we take the lower bound there, which is our OME. That is the reason why we have a 30 there, because that is the lower class limit of that class. Now, we want to find the class width. So the class width, you remember, we said you can use upper boundaries or you can use lower boundaries. So in this case, if we say, we use the lower limit of this class and the lower limit of this class, we say 20 minus 10, we get what? 10. So that is the reason why there's 10 there. Even if you come and take this 2, 59 minus 49. You remember how to calculate the class width from what? From the previous lecture, right? You can take two upper class limits that are neighboring or consecutive to each other or adjacent, or you can take two lower limits that are adjacent to each other, right? So even if you take these two, 39 and 29, you still get 10, right? So our class width there is 10. Then our n is 20. That's why there's a 20 there, over 2. Then less than, then this is the cumulative frequency, right, of all the intervals, of all the class intervals. So if you add this and this, you get 7. So that is the cumulative frequency of the previous class. You just take the cumulative frequency of the previous class to the median interval, right? So that's the reason why we took that 7 there. and we put the 7 there, divided by frequency of the median class, which is 6, right? And then we put the 6 there. And then we calculate. So the median in this case is 35. So it doesn't mean somehow, for this example, the median and the mode, they're the same, but it doesn't mean that they are the same, right? Because the formulas are different. But somehow, for this example, it was the same, but that is how you calculate the median. And then the mode now, the reason why you can see that the equations that are in your study module for the median and for the mode, I changed them, is because there's a certain way that your lecturer wrote it that is a bit confusing for you. So I just put this one, because remember, at the end of the day, what you need is to kill the cat. There are many ways of killing the cat, right? You can put it in a sack, and then you can throw it in a river. You can put it in a sack, you can take a rod, and then you can beat it, or you can take a knife and cut it. There are so many ways of killing the cat. So what you just need at the end of the day is the answer. Because remember, your OSA, your online assessment, assessment, right? It will be a multiple choice. So they won't ask for the method. They want you to have the answer. So what is much more important is for you to have the correct answer and prove that the answer that you got is the correct one. So that's the reason why I put this one. This one is so effective, right? For all the past lectures that I've been having for statistical techniques, I've been using this, and students were really happy with this because it's straightforward, right? So now for mode, what you need to do is you need to find what is called also the modal interval. The modal interval is again the interval that has the highest frequency. So when you find the modal interval, which is the interval with the highest frequency, you take the lower limit, the lower bound, which is your OMO. Then you say plus C is your class width. Then FM, that's your frequency, right? The frequency of the modal class. Then FM minus 1, that is the frequency of the interval before or preceding, before the modal interval, right? And then FM plus 1, that is the frequency of the interval following the modal. So I'm going to do this practically next week, and then I'm going to maybe to give you a handout, right? So that you can constantly refer to this even when you're writing your examination, so that you don't forget these two, right? The FM1, FM minus 1, and FM plus 1. Don't worry, I'm going to properly give you a handout that will explain this next week, right? Today I just do the theoretical part of it, right? Then coming back to the table, right? We need to first find the modal interval, right? The modal interval, right? In this case, it is what? In this case, it is the interval with the highest class, right? So with the highest frequency, sorry, the highest frequency in this case is 6. So we take this class 30 to 39. So that's the reason why here OMO there's a 30 there, because that's the lower limit of this class, right? And then C again is class width. You can take any here, 40 minus 30, you still get 10. Then FM, that's here 6 there, minus then your FM minus 1, that's the class before, which is 5. Then the 4 here is the class after, all right, which is your 4 there. When you what do you call it, when you simplify this, you get your mod as 33.33 cars that were sold. So that is how you calculate the mod. So recap, we are just saying there are 2 types of data, right? 2 data types, right? There's what we call ungrouped data. There's what we call grouped data. So when it comes to measures of central tendencies, that is your mean, your mode, and median, they are different formulas for those different types of data, right? There are formulas only for ungrouped data, and there are formulas only for grouped data. So you need to understand the type of data that your lecturer gives you in order for you to know which type of formulas are you going to use. That is the reason why we took time to explain to you,
the differences of those types of data so that you will know which formulas to use where. So for today, we're going to end here. I don't want to saturate you with too much information because now this next section is about measures of dispersion. That is another branch of descriptive statistics. So for today, let's end here for the sake of because of this, this complicated, formulas. I just want you guys to take time to what do you call it, to refresh, right? We'll pick it up next week, right? Next week we'll pick it up there, and then I'll do an example with you guys so that you can really understand. Because here this was just the theoretical part, but next week, because this was an introductory, next week we are getting into the practical part of it. So I will show you on Excel, I will show you on the Word document and on the whiteboard how to calculate each and every element of the measures of central tendencies, and I'll try to make sure that you guys, you master it in the best way possible. All right, so I'm not so sure if there are any questions. If there are any questions, just feel free to ask. I'm seeing Theo Beaton and Tanya. Thank you very much for your feedback there. I don't know if maybe there's anyone else with something, maybe a question before we call this session off. All right, so I'm assuming that the silence, it means that everyone is content, and also the feedback there, I think is positive, shows that people were really getting what I was trying to bring out. So thank you very much for your time and your presence. So we'll pick it up next week where we are going to get into the practical part of it. So have a lovely evening. See you next week, same time.
Thank you, sir. Same to you as well.